everyone, we're going to find the area of the region that lies inside both curves. We have 2 roses here with 4 petals. I made the green one cosine of r equals cosine of 2 theta, and the red one is r equals sine of 2 theta. And what they want is the area of the region that lies inside both curves. So that's going to be this little area in here. There's 8 of these. Now it's kind of hard to see, but that kind of helps to do a little sketch or use your calculator and see what's going on. So there's 8 of these. Now I need to find, since there's 8, I can just take the area of one of these. Let's do this one. So I want to find this intersection here to see where I can, what limits I need to put for my integral. So set sine of 2 theta equals cosine of 2 theta, and divide both sides by sine of cosine of 2 theta. So that's going to equal 1. So tan of 2 theta equals 1. We want this to equal pi divided by 4. That's in quadrant 1. So set 2 theta equal pi divided by 4. So our angle is going to be pi divided by 8. So let's look and see where that is. It's right in here. Pi divided by 8 is right here. Let's see if I drew it right. Right in here. I kind of got it. I'll make it. So basically what we're doing is we're taking this area and we're also dividing it in half as well. So basically we got this upper half and this lower half. So technically when we take the area, we're going to go from 0 to pi divided by 8. And we're going to use the red one. So if we're going from 0 to pi divided by 8, we want this upper portion here of the petal that shares both. And that means we're just going to use this one, r equals sine of 2 theta, because that would be 0 to pi over 8. If we use this one and did the same thing, we would only get this part right here, the part that's not shaded. So be careful with that. So we're only going to use this one and then basically multiply everything by 16 because we're only taking half of that of that. So let's see what we have. We're going to take area equals 8, and then we're going to multiply it by 2 again. So it's really 16. And then we're going from 0 to pi divided by 8. And we're just looking at this curve right here. So this is going to be 1/2 and r squared. So this is going to be sine squared of 2 theta d theta. All right. So these two are going to cancel out. So now we're just left with 8. And times the integral from 0 to pi divided by 8. And what I'm going to do is use my identities to make integration easier and write this as 1/2 times 1 minus cosine. Usually we use 2 theta, but now that we have a 2 here, it has to be 4 theta. All right. Now let's go ahead and integrate. I can multiply these two, so that's going to be 4. And when you integrate, you're going to get theta minus 1/4 sine of 4 theta. And we're evaluating from 0 to pi divided by 8. All right, so we're going to get, for pi divided by 8, you're going to get this equals 4 times pi divided by 8 minus 1/4 and then times 1. This is minus. So your final answer is going to be, when you multiply this through, your area is going to equal pi divided by 2 minus 1. And that is your area of the whole shaded region that lies inside both curves. Thank you. Have a nice day. Bye-bye.